On December 19, 2025, just 9 days before Christmas, an object from another star system will come to its nearest point to Earth. This event will take place without any sirens, breaking news alerts, or emergency notifications on your device. Instead, on mountain peaks, in deserts, in icy valleys, and atop city buildings, telescopes will calmly focus on a specific location in the sky. On their screens, a tiny blue smear of light, known as 3E Atlas, will emerge. For most observers, it may seem insignificant, but for those tracking it closely for months, it represents a question that the universe demands we address. Over the past year, we've consistently been informed that 3E Atlas is a comet, an unusual one, indeed, but nevertheless a natural occurrence, a dirty snowball, a frozen remnant, a fleeting visitor that leaves behind little more than dust and stunning images. However, as December 19th approaches, the validity of this narrative becomes increasingly difficult to uphold. The closer we examine this object, the more it behaves as though it hasn't received the memo on how comets are supposed to function. Let's talk about the timeline. Right now, while you're listening, we're just 9 days away from an optimal viewing opportunity. On December 19th, the alignment of the Sun, Earth, and 3E Atlas will create the right angle for a side-lit view. The comb of the bright, glowing atmosphere of gas and dust surrounding the nucleus may thin adequately in just the right direction, allowing us to see the solid core for the first time. This window of opportunity will be fleeting. The object is already on a hyperbolic trajectory away from us. Following this flyby, it will move outward, crossing Jupiter's orbit by March 2026, before disappearing entirely by the early 2030s, a ghost retreating back into interstellar space. We have only this one real glimpse, and everything we've observed so far suggests we should take it seriously, as 3E Atlas has already defied nearly every rule we utilize to understand comets. When Hubble focused on it on November 30th, experts anticipated a disordered, chaotic object, especially after it had just passed perihelion, when the sun's heat usually causes comets to disintegrate, vent uncontrollably, and shed fragments, revealing fractured, elongated cores. Instead, Hubble detected a tightly concentrated nucleus enveloped in a smooth, symmetric halo nearly 40,000 kilometers wide, with no visible fractures, signs of breakup, or hints of a nucleus being torn apart. However, embedded in that glow, enhancement filters uncovered something even more intriguing: a narrow, focused spike of material extending about 60,000 kilometers toward the sun. This inward-pointing sunward spike defies standard comet physics because comet tails are expected to point away from the sun. Solar radiation and the solar wind dislodge gas and dust, pushing it away from the star, creating ion and dust tails that always stream in the opposite direction. Instances where a tail appears to point inward occur only when Earth's perspective aligns perfectly with the comet's orbit, creating an optical illusion. In those cases, the material isn't inherently directed toward the sun. It just seems that way from our viewpoint. But 3E Atlas refuses to abide by that explanation. The sunward feature existed before perihelion and continued afterward, flipping its orientation in relation to the comet's motion, yet persistently pointing toward the sun. It did not disappear when the geometry shifted, it remained present. Adding to the strangeness, the length and form of that inward spike closely matched a prediction made before the Hubble images were captured, a model that presumed 3E Atlas was discharging macroscopic fragments, solid pieces, not merely gas, during its pass near the sun. According to the model, these fragments should drift under non-gravitational forces to a position approximately 60,000 kilometers in the sunward direction by late November. The observation corresponded precisely to the prediction, not vaguely, but with remarkable accuracy. Natural outgassing is typically chaotic, rarely producing geometry that is predictable months in advance with such precision. Here we stand, mere days away from closest approach, contemplating an object whose most inexplicable characteristic was outlined before we even observed it. The evolution of its color has been equally puzzling. Initially detected with the expected deep reddish hue of interstellar objects, its outer layer baked by cosmic rays over millions of years, 3E Atlas transitioned to green as it approached the sun. This change is a classic signature of diatomic carbon and cyanogen triggering under solar heating. While strange, it's still within the realm of cometary chemistry. As it moved away from perihelion and cooled, one would reasonably predict it to fade to gray. However, it instead turned an electric blue, a vibrant shade typically associated with ionized gases, energetic discharges, and heated plasmas. Here on Earth, we see this hue in welding arcs, lightning, and the eerie luminescence surrounding nuclear reactors. In space, it suggests gases are being elevated to extreme energy levels. Yet, as 3E Atlas moves away from the sun, the sunlight input is decreasing, not increasing. Outgassing should be diminishing, activity should be subsiding, and the object should be settling down. Instead, the blue emission is intensifying. One conservative theory posits that the sun has stripped away the weathered red surface, revealing a fresh layer of volatile ESOS from another stellar system, which just happens to glow blue under added energy. While that would be odd, it isn't impossible. The issue, however, is that the blue emission does not dissipate as the object cools. It remains constant even as the solar energy available declines. This leads to a question some researchers are quietly debating. 1. They hesitate to voice aloud. What if the blue isn't merely a chemical manifestation, but an indicator of energy output? If an entity such as 3E Atlas were utilizing the sun for an O-berth maneuvered diving close and then activating some form of propulsion at perihelion to maximize thrust energy, you would expect to see an initial burst of activity followed by a residual glow as the system wound down, a progression of colors: red from an irradiated crust, green from standard cometary volatiles, and then blue from high-energy exhaust. Suddenly appears less random and more like a three-stage process. Not definitive proof, but difficult to dismiss. Moreover, the chemistry is intriguing. Radio observatories like ALMA have detected significant amounts of methanol and hydrogen cyanide within the coma of 3E Atlas. These aren't just any molecules. Methanol is a fundamental fuel for certain microorganisms and a frequently encountered building block in astrochemistry. While hydrogen cyanide is toxic to terrestrial life, however, under the right conditions, it plays a crucial role in forming adenine, a core element of DNA and RNA. The ratio of methanol to hydrogen cyanide around 3E Atlas is extreme, approximately 12:1. We've encountered something similar just once before, in a well-known odd comet within our solar system that pushed the boundaries of what we deem standard chemistry. Now, envision that same chemical profile originating not from a local object, but from one that formed in a distinct stellar nursery with different radiation and elemental compositions. If one subscribes to the theory of natural panspermia, the idea that life's building blocks are conveyed from star system to star system by rocks and ice, then 3E Atlas represents a dream scenario. With high methanol levels, ample hydrogen cyanide, and global cryovolcanic eruptions near perihelion ejecting this chemistry into space, it appears to depict the seeding event, an organic messenger delivering prebiotic material into a new system. Nevertheless, the specifics further complicate the straightforward narrative. 3E Atlas isn't merely releasing gas into a uniform cloud, it's emitting material in structured jets, featuring a persistent antitail and significant solid particles amidst the outflow. Observations reveal it's shedding not only fine dust, but also gravel-sized chunks that are too substantial to be blown away swiftly by solar radiation pressure. Dust may exit the solar system within weeks or months, but larger pebbles can linger for decades, centuries, or even longer. If one aimed to leave markers, seeds, sensors, or simply chemistry meant to wait until it impacts a planet, fine dust wouldn't be the choice. One would opt for exactly what 3E Atlas is currently trailing in its wake: the signals we detect from it in radio frequencies contribute another layer to the analysis. Telescopes have captured steady emissions at frequencies linked to hydroxyl radicals, which are precisely what you would anticipate if solar radiation is cleaving water and other molecules. A straightforward case of natural photochemistry. Case closed. But the signal is remarkably stable. Typically, comets that outgas in jets produce fluctuating radio signatures that brighten and dim as active regions rotate in and out of view. With 3E Atlas, however, the emission resembles a constant hum rather than an irregular heartbeat. This is yet another data point that doesn't quite fit the molds we continually attempt to place it in. At the core of all this is an additional mystery that becomes crucial as we progress into these final 9 days. The movement of 3E Atlas is distinctive. Interstellar objects typically enter on hyperbolic trajectories, primarily shaped by gravity. On the other hand, comets that outgas often undergo minor non-gravitational however, these are usually messy, leading to unpredictable shifts in the object's course, altering its spin and wobbling its path while introducing noise to the orbit. In the case of 3E Atlas, the non-gravitational acceleration is unusually clean. Instead of making the orbit fuzzier over time, recent measurements have continued to sharpen the fit. As increasingly comprehensive datasets from various observatories are collected, the predicted path becomes clearer, not blurrier. Minute deviations from a purely gravitational trajectory appear to be directing the object into specific alignments with major celestial bodies, including an upcoming close encounter with Jupiter's Hill sphere that will be measured in tens of thousands of miles out of tens of millions. This level of precision typically denotes missions designed using computers and adjusted with thrusters, not icy rubble. And now, we return to the present December 10th, just 9 days ahead of closest approach. This moment divides the astronomical community into two distinct discussions. The public dialogue is reserved, conservative, and even somewhat apathetic, referring to it as a fascinating comet or an extraordinary interstellar object, a valuable opportunity for scientific discovery. The private discussions, on the other hand, offer a much more candid perspective. There are numerous anomalies that cannot be easily dismissed. the persistent sunward the successful predictions of models accounting for macroscopic fragments, the red-green-blue color evolution deviating from expected heating patterns, the chemistry appearing almost purposefully tailored for prebiotic reactions, the substantial debris failing to disperse, and the smooth non-gravitational acceleration. None of this provides definitive proof of intent or engineering, but all of it warrants closer scrutiny. On December 19th, the curtain may rise. If the coma thins and the geometry aligns favorably, we may finally catch a glimpse of the nucleus, its shape, reflectivity, and texture. Will it appear as a jagged, irregular rock, a loose rubble pile, a fragmented shard, or something more refined and symmetric? We may only gain silhouettes, hints, or a few pixels that are brighter or darker than their surroundings, but those pixels could shift the debate significantly for years to come. Once that moment passes, the opportunity will cease. 3E Atlas will continue its journey outward, crossing orbits and leaving behind a trail of gas, dust, and pebbles that will become part of our solar system. Whether we welcome it or not, some of those particles may eventually enter our atmosphere in the years to come, too small to be noticed, yet large enough to bear whatever chemistry they contain. Perhaps it's merely amino acids adding to the extensive pool that already exists. Or perhaps it holds nothing related to life at all. Maybe it carries compounds, still unnamed, born under conditions never present in our vicinity. The most disconcerting possibility is that 3 Atlas is utterly indifferent to our existence, neither a messenger, a weapon, nor a gardener, but something executing a task unrelated to humanity. It doesn't decelerate as it gets closer. It doesn't emit narrowband radio signals or display conspicuous patterns in visible light. It doesn't curve its trajectory towards Earth. It simply continues onward, steadily and uneasily navigating through gravitational contours as if they're landmarks in a landscape it comprehends. 9 days from now, telescopes will take aim as images are captured and data begins to stream in. We may discover that 3E Atlas is merely the most peculiar natural object we've encountered, a statistical outlier that stretches our models without breaking them. Or we may uncover indications that something else is unfolding, something that compels us to reconsider what it truly means for an object to traverse a planetary system. As we count down to the impending closest approach, here's the vital question to ponder. If this is indeed our sole opportunity to observe an interstellar visitor up close, and if there's even a slight chance that it's not just another rock, what should we choose to investigate? Signs of chemistry, evidence of structure, indications of intent? Share your theories in the comments. Do you lean towards it being a comet, a vessel for natural panspermia, or towards something more probe-like that defies conventional categorization? Be sure to subscribe to stay updated on what unfolds on December 19th. Because whatever 3 Atlas truly is, we won't encounter another object precisely like it on the same trajectory again in our lifetime, and the narrative it's crafting across our sky is nearly complete.